Down in number 19, there are many of the terms that we've talked about, but now we're going to look at it in terms of actually taking the derivative. So in part A, it says find the displacement. The displacement is a change in the position. So I'm going to find out where is that object at 0, and that would be 2. And then I'm going to find out where is the position at 5 seconds. And if I plug a 5 in here, I get 25 minus 15 plus 2. And so this ends up to be 12. So its initial position was 2. After 5 seconds, its position was 12. So that means its displacement would have been 10 meters. Okay? Now, for part B, the average velocity is the displacement over time, or the change in position over time. So that's s of 5 minus f of 0, which we just calculated to be 10, and then we're going to divide that by 5 seconds. So that would be 2 meters per second. Now, that is the average velocity. For part C, the instantaneous velocity is s prime, which in this case would be 2t minus 3. Okay? Now, the instantaneous velocity when t equals 4 would be, this would be 8 minus 3, so that would be 5 meters per second. So the average is 2 meters per second. The instantaneous is 5. And then for part D, the acceleration would be the derivative of the velocity. So acceleration, which would be v prime, and that would be 2. Now, we want to be careful of our units here. This is going to be meters per second squared. Now, at what value of t does the particle change direction? Well, we know that the velocity is 2t minus 3. And so when t is 1.5, it's going to be 0. Prior to that, it's going to be, if I make a little chart like this, okay, and here is at 1.5, the velocity, okay, I'm going to label this with velocity. At 1.5, the velocity is 0. When t is greater than 1.5, let's say 2, this is going to be positive over here. And then between 0 and 1.5, it's going to be negative. So when does it change direction? It changes direction at 1.5 seconds. So at 1.5 seconds. And then for part F, when is the particle, when is S at a minimum value? Now, if we take a peek here, we notice that S is a quadratic. When you have a quadratic, it's going to be a shape like this, it's going to be the shape of a parabola. And when will it be a minimum? It's going to be a minimum right here. And that is when the derivative is 0. We already know that the derivative is 0 at 1.5, so now we just have to find it out. What is s of 1.5? And if you plug 1.5 into that original function, you will get negative 0.25 meters.